Hello guys, in this video I'm going to tell you how you can create your own function in R. Okay, so we'll see how is the function defined. We'll also see what is the return statement. So basically just to tell you what to return. Tell the function what to return. Then we'll tell you I'll tell you how we can put default values to the arguments. We'll just define a Gauss function for that. Then we'll see what is lazy evaluation and the dot argument, and finally the global variables. Okay, so without any further ado, let's start. Okay, so this is how you can define a function. You say f, so your function name is over here. Let me just yeah, so it's like function name is equal to function. That's the keyword. This is the keyword function, and then you have arguments. So over here I have just put one argument, which is num. Okay, and then you open your bracket, and yeah, it's something like this. Oops. Yeah, something like this. Open bracket, close bracket. Okay, so that's how the function is defined. So over here it's a very simple function. I've called a for loop for I in sequence length num. So that will just give me, so num is like a number. Say if I put 3, so I in sequence length 3 will give me 1 to 3 numbers. So 1 2 3, and then what it'll do is it'll just paste hello world. Okay, so cat is a new function. So cat is just similar to print, but in this you can actually use these kinds of things like backslash n is to just give an enter. Okay, if I don't put this, let's see what happens. Oops, it could not find the function because I have not yet executed this. Yeah, see, it says hello world, hello world, hello world in the same line. So if I just do a backslash n, now you get this like this. Okay, you can also use the print statement. So print statement does not recognize these things. Yeah, so that is what the print statement will give you. Okay, you can also change the number of arguments. So that'll give you 4. So yeah, so this is a function. So this is how we call a function. That's function name brackets your this thing. Please note the importance of the brackets. There are round brackets over here. So if it would have been a variable, a matrix or something, so say a is equal to matrix 1 to 4 2 comma 2. So now a is a matrix. Now in order to access the elements of a, I use square brackets. Okay, so please make sure you know this. So for matrix or other variables you use a square bracket. For functions we use round brackets. Okay, then there's the return statement. So if you want the function to return something, then that's placed over here. So say I'm just calculating the factorial of a number, so I get an input, that is the number, and the output should be the factorial of the number. Okay, so say I just have a dummy variable res is equal to 1 for now, and then what I do is for I in sequence length number, so say initially number is equal to 5, so what will happen is I will go from 1 to 5, so that is 1 2 3 4 5, and then what will happen is, so rest is initially 1, so that will be 1 into 1, and that will be stored into rest. Then I will become 2, so that will become 2 into the previous value of rest, which was 1, so 2 into 1, that's 2, so rest is now 2. Then 2 into 3, so now rest has become 6, and so on. So like this a loop will go and you'll get the factorial in rest output. Okay, so let's just run this. Okay, so say I want the factorial of 5, So you get 120. That's a factorial of 5. Okay. Also note that if you place a 0 over here, so what happens is sequence length of 0 actually gives you nothing. I mean, yeah, let me just show you. So if you have a 0 over here, you get nothing. Okay, so that is why because of that the for loop will never execute, and you are just having res is equal to 1, so your answer of factorial of 0 is 1. Okay, so that's how, and I'm saying to return res, that is return the result. So yeah, it'll return this particular value. Okay. Okay, what if we want to put some default values? Okay, so you can just put that over here. So this is a basic Gauss function. So it is like a bell-shaped probability curve for those people who don't know. So very important curve for statisticians. So what I'm doing over here is I'm calculating the probability, the Gaussian probability, and for that what I need is I need the data point. So n will be our data point. Mean, I need a mean and standard deviation. So the mean for now is 0, I mean the default value is 0, and the standard deviation, the default value is 1. Okay, this is the Gaussian formula. 1 by 2 pi into standard deviation into exponential of minus n minus the mean the whole square upon 2 standard deviation square. Okay, so this is a basic formula. You just get that. And what I'm going to do is just plot the function for you. So I define a t variable, which is nothing but a sequence from minus 0.1 to 0.1, and it has 10,000 values. Okay, so t will, the first element of t will be minus 0.1, the last element will be 0.1, and then it'll be a length of 10,000 elements, which will be between minus 0.1 to 0.1. Okay, that's my t. And then I simply use plot t comma Gauss of t. Notice I have just put one t, just one t, I mean just one argument, so it just takes n. That's it, because mean, if you don't specify the mean, it assumes mean to be 0. If you don't specify standard deviation, it assumes it to be 1. Okay, so yeah, I mean you can also do something. So say for now, let me change this to 0.05. So the mean has now become 0.05, and let the standard deviation be 2. Oh, I did not execute this. Yeah, you can see the curve has changed. So now the mean of Gaussian has become 0.05. Okay, and yeah, so that's how you can, I mean, give the arguments. Also, if you're not familiar, this is so this is the plot. If you don't put a type, it'll look something like this. Okay, so these are actually small circles, and there are a lot of small circles which has made it a solid line. But yeah, and you can also see different types over here. I mean, I guess you won't be able to see it over here, but okay. So I recommend you to just see the different types in the plot function. Okay, maybe I can do that by, yeah, okay, yeah, I can do this. Okay, so but just by reducing the number of elements, you can see this is how B looks like. So it's like dash O dash, and this is how L looks like. So it's like line, L for line, and then this is the original. So the original is just dots. Okay, so yeah, so that's the plot function. Yeah, now you can also change the order. So here I had put the data first, data point first, then the mean, and then the standard deviation. Now what you can do is you can just write, if you know what are the arguments, you can just write, say mean is equal to 2. Notice I've written this in the start. So mean is equal to 2, standard deviation is equal to 1, and then I've put 3. So R understands that, okay, mean is 2, standard deviation is 1, and the last thing is actually what is left. So over here the data point is left, so yeah, that's it. And it gives me this probability value. However, what I can do is I can just put 3 to 1, that is in the same order. I have not mentioned what is the mean, what is the standard deviation. So what the function will do is it'll take 3 as the data point, 2 as the mean, and 1 as the standard deviation. Okay, so this is exact same. Okay, these two things are exactly the same. The data point is 3, mean is equal to 2, standard deviation is equal to 1. Okay, and you can see that the answers are also exactly the same. Okay, the other way that you can do is, say you remember there's a mean and you say mean is equal to 2, and then you like go back and say see the function. So you can do this as well. So mean is equal to 2 and then you put 3 and 1. So after whatever is known, I mean mean is equal to 2, this is in some sense known, but you're assigning the value of mean is equal to 2, and then what happens is whatever is there after it, it will go in the systematic order. So once mean is known, so this is done, then you go in the same order. So if there is a 3 over here, R will consider this 3 to be n, because that was the first argument actually, and then whatever left is standard deviation. So whatever left is standard deviation. Okay, so you can do this also. So again, I mean, these three examples are exactly the same. They're giving the same output. The only thing is in the way that you're giving the arguments. So over here you're defining the arguments like this. Over here just you're using the order, and here you are using both in some sense. You're also using the order and defining. Okay, so that is how you can actually call these different functions. Uh, then an important thing about R is that it is, so this is known as lazy evaluation. So R will not use a particular variable until it is called in the function. So let me just clear that for you. Let me just make that clear for you. So let me define a function which is a special square function. It takes two arguments a and b. What I'm doing is the result that I want to return is nothing but a squared. Okay, the result is a squared. If a is greater than 3, then I want the result to be a plus b the whole square. Okay, so notice if a is less than 3, you don't need b. Okay, so let's say, let me just evaluate this function. Yeah. Okay, so if a is equal to 1, so I'm putting the value of a as 1, and I just don't put b. Okay, it still works, because so what the function does is it has a, it'll go inside, it sees, okay, here a is used, a squared is 1, it puts that into the result. It checks if a is less than, if a is greater than 3, it's so 1 is less than 3 in this case, so it never goes into this if loop, so it never encounters b and just returns the result. Okay, so it does not need a b value over here, so just a is enough. Okay, until and unless a is less than 3, this will work. But as soon as you put a greater than b, it will give you an error, because there is no b. Because when a becomes greater than b, a becomes greater than 3, what happens is you have to do a plus b the whole squared. Okay, so this will now give an error, because it requires b to calculate the result. So if a is greater than b, greater than 3, then you need to specify a b. Okay, so this is what they call as lazy evaluation. So until and unless you don't encounter a particular variable, it does not matter if you have specified it in the arguments or not. Okay, so this is the lazy evaluation. Okay, the other thing is you can also use the dot 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 argument. So the dot 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 argument is for actually for user defined functions. So for inbuilt functions, so here say I'm defining my function which is say pr paste. Okay, and what it does is it takes a that is a string over here. Also note that you don't need to define what data type are the variables. R just understands it and uses it. I mean, so if over here say you put an a, it'll give you an error because it needs numeric input over here. Okay, so based on what functions you do over here, it automatically determines this is the best data type. So so this string is not a good data type. Okay, for it, so you don't need to define the data type. Okay, so over here I'm going to pass a string, and what it is going to be is the following. So I'm going to use paste and say Pratik a and so on. Okay, so when I execute this and I say okay, I hope you're liking this video, and then I run it. So you see I get a Pratik in the start. Okay, so say you want to create a dialogue for some purpose, so you can do this. However, it would be better if I would have a colon over here. So what I can do is, so in the paste function, it has something known as separation. And yes, I want to separate the two strings that I heard by a colon. So now you can see there's a colon over here. So now this is an argument that is actually a paste argument. So argument that can be given over here. So these three dots actually are used for that. So if you have certain functions, certain inbuilt function that you are going to use in your own function, you can just put this dot 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 over here, and then what happens is whatever extra arguments you put after your argument. So after I've put my a, whatever extra I put directly goes to the paste function. Okay, so yeah, this is pretty useful. Okay, so yeah, so that's one thing. Yeah, so I've just defined this over here. You can also change the separation to something else. Oh, you cannot use the backslash, you have to use this. Yeah, okay, backslash is actually a special character. Oh, it is not a special character here. Okay, no problem. Okay, so yeah, you can use anything. Okay, so that was about this dot 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 argument. Then you have global variables. Okay, this is an important concept. So so let me just execute this function as the following. So I have a f function. It's going to take an input x that is equal to 1 for now. Okay, and let me just remove this for now. Okay, so this is just equal to over here. Okay, so what I'm going to do is so this is a small function where I have defined an argument that will take x is equal to 1, and I'm just going to increment x by 1. That's it. And I don't know why there's a y over here. That's it. And I'm going to return x. Okay, so you can either type return x or simply just put x. That's the same. Okay, so yeah, so this is my small function, and let's see what happens. Okay, so yeah, so now I've printed some cases over here. Let us just one by one see all the cases. Okay, so here I have globally defined a new variable x. Note that this x that is there over here is limited to the function. Okay, uh, it is created inside the function, and as soon as it comes out of the function, this x actually dies. Okay, so over here the x that is here is the x local to the function f. Okay, however, this x that is outside the function, any x, any variable that is defined outside the function, oh, this become any x that is defined outside the function is a global variable. Okay, so now let us just see what happens if I just print f of this thing, f of that's f without any arguments. Okay, let us see that it says 2. Okay, so here I did define x is equal to 9, then it came over here, said print f of x, so it went to my function f. Here, because there was nothing, it took the default value of x as 1, incremented the default value of x, that is 1 plus 1 becomes 2, and returns x, so it returns 2. Note that this x that it returns is different from what I had mentioned in the global variable. So that is what I want to say. This x is totally different. This is a global variable, and the x that is over here is a local variable that is very different from this x. Okay, I hope you get that. Okay, let us see the other examples. Now over here I say print x. Okay, just x. So when I just print x, it is not calling any function, no functions. Okay, so it is this x that it is printing, no function. Just I'm outside all the functions, just printing the value of x. So the actual value of x outside all the functions is this, that is 9. Okay, now let's see what happens when I do f of x. Okay, so here I'm doing f of x, it gives me 10. So what is happening is currently the value of x is 9, so that 9 comes over here, that is 9 comes over here, this x now becomes 9 because I passed that value over here. That 9 is now updated as 10, so 9 plus 1 becomes 10, that is stored as x over here, and then that 10 is returned, so we get 10. Okay, and yeah, this is again print x. I don't know why did I do this. Okay, so that's how local or global variables function. However, I can change this and put a super assignment over here. What happens when I do a super assignment is that this x that is over here becomes the local x. Okay, let me just do this. So I have global x super equal to small x plus 1, and then small x is nothing but the local x. So over here, if I just place double this sign, whatever this sign is, if I do this, I'm just forcing the value of x that is outside to change. Okay, so this is what is happening. Just let me show you what happens when I do this. Okay, so now let us just again see the global variable that is outside is 9 for now. Okay, and what I'm doing is I'm saying print f of this thing. Okay, let's see what happens. You see it gives me 1. Okay, so what happens is over here it comes, I mean, so initially x was 9, print f of this, so I've not put any arguments, so that makes this over here this local x, the local x over here becomes 1. Okay, now over here what is happening is this is a local x, that is 1 for now, plus 1, that's 2. This 2 is actually printed to the global x. Okay, so this particular statement is actually changing the value of global x and not the local x. Okay, so here this local x remained 1, it did not increment, and hence I got the value 1. Notice that. I hope this is clear. Okay, so what is happening is just one more time so that you understand it correctly. So what's happening is initially the global variable was 9, this x was 9, which is outside all the functions. I called this function. Over here there is nothing, so there is this local x which became 1 because of the default value. This local x that is over here, that is 1 plus 1. This value went to the global x, that is, this particular statement actually changed this value. Okay, so now this has actually become something else, and that is 2. Okay, this has become 2. Small x, or I will say local x over here, has not changed. Okay, because this increment is only for the global x. Okay, so the small x did not change, or the local x did not change, hence the same x is returned over here as 1. That did not change. Okay, now let's see what happens over here. So it says print x, there is no function over here, so this will actually print the global x that is outside all the functions. Okay, the global x, you see that this is 2. Why is this 2? Because in the earlier statement over here, in the earlier statement, I actually updated the value that was initially 9 to 1 plus 1, that is 2, and that's why this global x became 2. Okay, now let's see what happens over here. F of x. Okay, so now this x that is over here is the global x, so it is 2 for now. So over here what is happening is now the local x will become 2, and then this will become 2. Let me just run it so you have the answer with you. Okay, so again, so what is happening is initially there was the global x which is 2, the global x went over here. Now the local x became 2 over here. Just for your understanding, let me make this 2. Okay, so the local x has become 2 over here. Now this has become 2 plus 1, that is 3. 2 plus 1, that is 3. But this 3 is actually updating the global x. Okay, so this global variable over here is now 3. This is 3. Okay, but still the local x is 2 because this did not change the value of the local x, and it here it returns the local variable, the local x. Okay, so this was still 2, and hence it did not change. However, now if you print x, now if I print x, okay, now this x will be the global variable that is over here. So it was 3, so it should actually print 3, and there it is, it's 3 now. Okay, you understand? So over here, by this particular super assignment, you can change the value of variables that are not inside the function, that are outside the function. Okay, so yeah, so that is how you can treat global variables inside a function. So yeah, so that was the video, guys. I hope you understood all these things. If there is any doubt, you can always put them into the comments below. And yeah, that's all. Thank you so much for watching. Thank you.